Hello, it's JP Hrisoulas, the cranky old bastard himself. Today we're going to discuss steels that can be used for bladesmithing. First off, let's discuss the different types of steels and the types of steels you need. Just about anything can be used as long as you can heat treat it effectively and know how to work it, and you can obtain it. There's a lot of controversy as far as what is and isn't a good steel. And a lot of makers have a tendency to jump around and use this steel over there. The next good steel comes over here. They do that one. The next best thing comes out there. All that does is confuse you. I believe that you should be able to thoroughly get the most out of any steel, know it intimately inside and out as far as working temperature ranges, forging ranges, hardening ranges, how to harden it, how to temper it back, how to basically use it. Because if you stay with 3 or 4 steels and use them over and over again, you get to really know them. That's what I do. I use primarily a 10 series, the 51 series, the 92 series, and the M series. Now, what that means is it tells you the types of steel. The easiest numbers to know are the AISI, the American Iron and Steel Institute numbers, and the Society of Automotive Engineer numbers, SAE. Whether we like it or not, we can thank the automobile industry for having standardized alloys, because they were the #1 user of irons and steels in the last 100 years, 150 years, actually going on now. And they needed consistency between melts, so they came up with a numbering system. It runs from 10, 20, 30, 40, all the way up to, as far as I know, 92. Most of the steels you'll be using are what they call 10 series steel, which is a plain carbon steel. That's the number for plain carbon. Another one you'll probably be using will be 41 series, which is a 95% chrome, 0.95% chrome, and a 0.7% molybdenum. Another good one is a 51 series, which is low chromium alloy. Those are basically in leaf springs and other spring appearances. It's got between 30 and 60 points of chromium in it. The next one will be 92 series, which is a bearing steel. It's got the 85% manganese, yeah, 2%, yeah, full 2% silicon in it. Very tough steel, but it's also air hardening. Those are the numbers, so get to know them. The labeling on some of these others for number steels are, like I said, 1 to 9. The first 2 numbers usually say what it is, and the second 2 numbers are the points of carbon, a point being 0.01%. So 5160 would be a 51 series steel with 60 points carbons. A 92 series, 9260 or 92100 would be a 92 series steel with 1% carbon. That's the easy one. Now, the numbers tell you what it is, but the letters will also help you, but not so much. The W series are water hardening steels. These are your W1, W2s. Your O1s, which are very common bladesmithing steel, at one time it was, is a very decent steel. The same with A2. A2 is an air hardening steel, but it can be forged and heat treated in the average shop if you pay attention. D2. D2 has been a standard steel for years. It is a die steel. That is what it means, die. W means water hardening. O means oil hardening. A means air hardening. D means die steel. Okay. S is silicone shock steel. M is machine high-speed steel. L is considered low alloy, and T is for tungsten alloys. The alloys you'll be using most on the letter series are probably W1 or W2 and D2, maybe L6 and M2. You can use other steels as long as you can harden them and as long as you can work them. Some of these steels are very, very, very hard to work under a hammer, such as D2 and any other air hardening steels. Plus, if you don't work with them within the proper ranges, you can crack the hell out of them. That's very frustrating. But if you work with them and you take it slow, and you don't rush things, and you're very thorough, you can do it quite easily. Well, I wouldn't say easily, but you can do it. A lot of these richer alloy steels, especially air hardeners, are what they call hot hard under the hammer. They don't move like a carbon steel. They are very resistant to impact deformation, but they're usable. All in all, know your heat treating, know your working ranges, and know which steels you need to use. I strongly suggest when you first start out to use either a 10 series or a 51 series steel. Both these steels are very forgiving in the working department. They're also very forgiving and easy to heat treat and temper at the home studio or the workshop out back or wherever you're working. They are oil hardening steels. Now, while I was thinking of oil hardening, let's discuss water hardening steels. When a mill says steel is water hardening, they're talking about cross sections in inches, not in fractions of an inch like we are using. You can, in smaller and thinner sections, effectively harden a W series steel, especially W2 or WHC, in a light oil. I've been doing it for years and get some great performance out of it. It does not embrittle it. It actually makes it a little bit tougher, and they are great steels. But your O series steels, you don't want to try hardening them in water. And even then, it's really not water, it's a brine solution. When I use W series steels and doing a water hardening, I harden them in my blue salts. The same when I do Japanese style blades with temporal. I use my blue salts on that, heat it to about 240 degrees, which is above boiling, but it makes a really nice blade. Other than that, those are things to remember. Also, where to get the steels, I would love to be able to tell you. It's just hunt around. You can use scrap, but I don't particularly condone that because you never know what condition the steel was when it was thrown out. Now, if you get mill cutoffs or a leaf spring manufacturer and you get the drops from the 52 or 51 series steels, that's an excellent source of 5160 and 5200 steels. Another one is any spring manufacturer, even coil springs are usable. That's a 92 series usually. Sometimes 62, but usually 92. L6, excellent steel. It's getting harder to find. 15 and 20 seems to be taking over for the L6 slot. There's another steel out there called Vascoware by Vasco Pacific. They went out of business years ago, which was sad because it was a fantastic steel. A pain in the ass to work, but boy, the performance you get out of a properly forged up blade with the right heat treating, oh man. Now, a word on heat treating. We'll get in that later on, but here's the deal. It doesn't matter if a blade is forged or ground. If the heat treating is great, you're going to get great results. If the heat treating isn't, you're not going to get any results. You can get better performance out of a mediocre steel with spot-on heat treating than you could with the most highest alloy steel you can imagine, with unobtainium, mined on the surfaces of Jupiter and Mars and imported, under the dark of night in the backs of hummingbirds. With crappy heat treating, the mediocre steel is going to beat it. So that's all there is to say on that. There's a lot more to cover. This is just a quick rundown. Here again, if you like the video, please hit the like button. Please hit the subscription button. I need subscribers. Tell your friends, tell your neighbors again. I'm trying to do my best here. I'm still shooting in the dark because I have no idea what I'm doing with this damn camera. But I'm having a little bit of fun doing it. So, thank you so much for your time. May the wise Lord keep you and bless you. Hit the like button, hit the subscription button. Have a good evening. Good night.